And welcome everybody to our bonus feature segment. This one's usually streamed live to Twitch. Today we made it into a recorded video instead. So we're looking at the total electron content forecast, and we're seeing some anomalies here, some very low electron contents. Check out how low the electron contents got there. Wow, like almost a lack of electrons, even around the equator at noon. Let's let that play through again, as we're seeing anomalously low levels of total electron content. So this will show you the most likely places for GPS errors, and GPSs are actually performing quite well around large portions of the planet at the moment. So what that shows you is the free electrons in between your GPS satellite and your handset. This satellite's located about 12,500 miles of altitude, just on the inner portions of the outer Van Allen belt. Looking at the satellite's community dashboard, we're seeing some significant surface charging hazards here caused by low energy electrons building up on the surface of the satellites. That's where those charging hazards are, places like Mexico and moving into the Central Pacific. Here's our GOES electron flux, relativistic electrons here, surprisingly high levels, and we are expecting this to be cratered here. We're expecting some additional coronal hole high-speed stream ejecta to show up, and at the moment, in warning levels for both the GOES 16 and GOES 17. Next, here's the forecast model. And NOAA forecasting a continued uptick. I'm forecasting a crash of the electron flux. We'll have to see what happens. There is some high-density coronal hole leading-edge wind having just arrived. We're expecting a big uptick once again in the solar wind speed. So it's already over 550 kilometers per second. There's the one-year chart for the relativistic electrons to put those in context. Next, we'll show the F-ionosphere layer. First, the ionogram showing vibrational frequency, and some major low-frequency anomalies there in the southern hemisphere, especially around the south polar region. And here's the anomalygram. This should clear things up if you're not used to looking at the regular ionogram. Lots of red on the anomalygram today. That's anomaly in megahertz from a 30-day median. A lot of low-frequency anomalies happening in the ionosphere. There's the latest image. 10 o'clock Universal Time ionogram. There's 10 o'clock Universal Time anomalygram. Continuing on to a ground-based solar observatory, as we do most days. Again, this video is usually streamed live to Twitch. Today we decided to make it a recorded video for all of you viewers on YouTube and BitChute. A bunch of filaments there in hydrogen alpha. You can see all those dark regions, a ton of filaments here on the earthly facing portion of the solar disk. Those could lead to additional coronal mass ejections. We are expecting 2 to strike Earth, one in about 2 days and one in about 3 days. From previous coronal mass ejections. Make sure you view our other content if you haven't at youtube.com/smashamash. We've been putting up space weather videos for over 5 years. Now, the SDO is down. The data hosting location is down because of a power outage at Stanford University. So no high-res imagery available from the SDO. However, here's 304 angstroms ionized helium from the GOES 16 SUVI. We've got a nice prominence down here by the south polar region. And that's our short bonus feature segment. Thanks for tuning in. Congratulations on realizing the Smash News Network least busted name in news exists. I guess maybe we have such a small following because we cite too many facts on the channel. See you soon, and may that solar wind be at your back.